Hi everyone, very good evening and welcome back to Geeks for Geeks practice and welcome back to another problem of the day as well. So today we'll be discussing yesterday's problem of the day, that is union of two linked list. So without further ado, let's get started. And if you are watching this stream, so please give me a +1 for a quick confirmation. So I will share my screen so that we can discuss the problem, and let me share it. Okay. So I hope that my screen is now visible to everybody. All right. So let us quickly open the POD as well. Okay, so I'll just open GFG POD and we'll see. Thanks a lot, Akash. So yeah, this was the problem, and basically in this particular problem, just a second, let me remove this code as well. Yeah. So in this problem, the problem says union of two linked list. So basically, we will be given two linked list, and we have to do what? We have to return the union of the two linked list in form of a in the form of a linked list in the sorted fashion. Okay. So suppose that if we have the first linked list, and suppose that the first linked list is like this. Just a second. Let me open this app as well. Okay, so yeah, suppose that we have the first linked list, and the first linked list looks like 9. Then after that we have 6, and then we have something like 4, and then we have 2, then we have 3, and then we have 8. Suppose this is there in the first linked list. Okay, this is linked list 1, right? Suppose the linked list 2 is there, and the second linked list is like 1, then you have 2, then you have what? Then you have 8, then you have 6, and then you have 2. Okay, so in this particular case you can observe that which elements are same. You can say that 6 is same in both of them, so this will come under the union. If you talk about the union, so I think every element will come. So just a second. So if you will see here now, so we can say that 1 is going to come, right? Because 1 is there in the union. Then I think 2 will also be there. Then you can see 3 will be there. Then after that 4 will be there. Then 5 is not there in any of them. Then you can see 6 is there, right? And 7 is not there, 8 is there, and 9 is there. So 1 2 3 4 and 6 8 9. 1 2 3 4 6 8 9, correct. So today's POD, please teach little slow. Okay, Akash. So basically now what we will be given is, we are given the first linked list and we are given the second linked list. Okay, and what we need to do is, we need to find the union of both, right? So we need to find elements which are present in both of the linked list, and we need to make a linked list finally, and we need to return in a sorted order. Okay, such that every element is occurring unique number of times. So if you will see one here now, so one is occurring here, so and one is not occurring in the first linked list, so one will be there in the final linked list. Okay, because I have to find the union. So union means that overall the elements which are present in the first or the second linked list. Okay, so I will take one. Then you can see that 2 is present in the first and second both. If it was present in any one of them also, then also I would have taken. So then we will take 2 also. After that you can see that 3 is present in the first linked list, not in the second. So still it will come under union because it is present at least one of them. Okay, then you can see 4 is also present here, right, in the second linked list. So first linked list, so we'll use it. Then after that 6 is there in the first and the second both, so it will also come under the union. Then 8 is also present in both of them, so 8 will also come. Then 9 is present in one of them only, so 9 will also be there. And 2 is present in the first, so 2 already I have taken, right? So in this case, when we are considering the union now, so if an element is consisted in any of the linked list, then I will consider it. Is this part clear to everyone? Please write yes in the chat. Okay, so I will see both of the linked list, and if an element is present in both the linked list or either in the first or the second linked list, so it will come in the union in the ascending order. Is this part clear? You can see that 1 is present, right? So 1 is present in the second linked list only, but it will come in the union because in the union you consider both first and the second linked list. Is this part clear to Akash and Black Shadow and everyone else also, guys? Please tell me yes or no. Is it clear or not clear, guys? This much part is clear or not? Akash and Black Shadow and other people also. Right. So what we have done is, basically we have taken the union of the first and the second. So you can see the union list should be including final union list should be in distinct order, distinct should be containing distinct element in the ascending order. So we are considering the ascending order here, right? So what we can do for this, so for this particular for solving this particular kind of problem, what we can do is, when we have to when we have to take distinct elements, okay, and we are also considering for the union. So union means an element which is present in any of the linked list or both of the linked list, that element is going to come under the union part, right? And for distinct element, we understand one thing, that whenever we have to talk about distinct elements, so whenever we don't want the repetitions, right, you can see that 2 is occurring here as well as here, and it is occurring here also, so it is occurring 3 times in including all both the linked list. So I have to always consider for the this part, for the distinct element. So when I consider, when I think about the distinct element, so the set data structure comes to my mind, right? Because set data structure only allows the unique entry of an element, okay? So an element can be present not more than one time. So how can we solve this particular problem here? So basically what we can do here is, we since we have both the linked list with us, right? So what we can do is, we can first of all declare a set data structure, okay, because it will help us to store all the unique elements, right? It will not allow any repetitions. So what we can do is, first of all, what I will do is, I will simply declare this set data structure, okay, in any of the languages. So in Java you can declare a hash set similarly, and in Python you can declare a set. So what we can do here is, we will first of all insert 9, then we will insert so we will keep on moving in the first linked list. So we'll insert 9, then after that we'll insert 6 as well, then after that we'll insert 4 also, then we'll insert the next element, which is 2. So we'll insert 2 inside the set, then we will insert 3 inside the set, then we will insert 8 also inside the set, and then we reach the end of the linked list. So that is when we'll stop. After that, what we will do is, we'll iterate through the second linked list. So we go to 1, so 1 is not there inside the set already, so we'll insert 1. Then we move to the next element, so the next element is 2. So 2 is already present, so when you will insert it, so nothing is going to happen, because 2 is already present and only unique representation is allowed. Then after that you go to 8, so 8 is already present, so in that case you will not put it. Then after that we go to 6, so 6 is already present, so we'll not insert it again, so it will not be reflected again. Then we have 2, so 2 is already present, so it will not be reflected again, okay. After this thing, what happens is, inside a set, since we are using a set now, so inside the set, what happens, the elements are stored in the ascending order. So inside the set, what happens after this is, I will tell you. So basically inside the set, you can understand one thing, that the elements are in sorted order. So first of all, inside the set, what will happen is, 1 will be there, then 2 will be there, then 3 will be there. When you will take out the elements one by one, so 1 will come out, then 2, then 3, and then 4 will come out, okay. 1 will come out, then 2 will come out, then 3, then 4, then 6, 8 and 9, okay. 6, 8 and then 9. So like this, the elements are going to come out of the set one by one, if you start to remove them inside from the set. Is this much part clear to everyone? So if this is the set, so all the union elements are stored. Union elements are nothing but elements which are either present in the first linked list or the second linked list, or in both. And I have to only take the distinct elements, right? So I don't want to repeat the elements. So that is why we are using a set. And apart from this, we also want the elements in the ascending order. So that is why we are using the set. If the elements were not asked in the ascending order, they were only asked in the if we were only asked about the distinct elements, then we could have used an unordered set also. But since we are asked about the scenario where we need to consider that the distinct elements should be in ascending order, so that is why we need to use the normal set here. Is this much part clear to everyone? Please tell me, guys. After this particular thing is done, so what we will do is, we can simply declare a dummy node, okay. So let's say we will declare a dummy node which can have the value initially as -1, okay. And then so we can name it as, let's say, head, and we will have a current variable as well. Then I will take out the first element from the front of the linked list, right? So basically, just a second, I will bring this thing down, this set down, okay. So yeah, let's bring it here somewhere. All right, so this is the set that we are having now. After that, what we will do is, we'll take out one the first element, so 1 will come out, and then we will make a node as 1. So we will do what, we will say current next is equal to this particular new node, okay. So what we are going to do is, we will declare the new node always with the set data, and after declaring the new node, we will say that current next is equal to new node, Okay, so is equal to new node. So basically for the current node, the next will be marked as the this new node. This is the new node, suppose, right? After this, what is going to happen? The current should move to the next. So current is equal to currents next. So in that case, what is going to happen is we can simply move from here. So this is the head, this is the right now this is the head, and this is where the current will move. Then after that, again a new node 2 is developed. So currents next I will make as new node. Okay, and then current is equal to current dot next. So basically current will move here. Then after that, I will take the next element. So next element is 3. So we will declare the new node as 3. And then after that, currents next is equal to the new node, and then current will move to this new node. So current will move here. So there is a 3-step process, you can understand. We take out the current, we take out this element, that is 4. We make a node out of it. Okay, so we declare it as a new node, and then currents next we attach it to the new node. Currents next is equal to new node, and then current will move to this node. Okay, so current moves right here. After this, again we will take out the element. So current minimum element is 6. So 6 will come out, guys. And then what we can do is 6 is the new node. So currents next is equal to what? Currents next is equal to nothing but the new node, and then current will move to the next node. So current will move to the currents next. So current will move here. Then after that, we take out the guy as 8. So this is the new node, and currents next is equal to new node will happen, and then current will move here, right? So current is going to be here. Then after that, we will have 9 here, and currents next. Okay, we will say that currents next is equal to new node, and then current will move here. And then after that, the set has ended. So everything inside the set has been taken. So this is the final linked list. Now if you are returning this linked list now, so if you directly return the head, so this is not going to be the correct thing. Why? Because actually, if you will see, so we had taken a dummy node, right? You can see here, this particular node was a dummy node, right? This was a dummy node, extra node that we had taken. So if we want to return the linked list, that is nothing but, if we want to return 1, then we want to return 2, then we want to have 3, 4, then 6, then 8, and then 9 only. Okay, if we want to have only these nodes, then in that case we don't want to return this particular node. So basically, from where do we want to return, or which linked list do we want to return? We will simply return what? You can say that we want to return heads next. Okay, because when you return, okay, when you will return heads next, right? So you can simply observe that when we return the head next, then in that case, this, from this stage it will be returned, and basically this will be nothing but 1, 2, 3, 4, 5, 6, 7, 8. So that is how the things are going to be done. Is it clear? Not able to solve even a simple solution of the problem. Not able to solve even a simple solution of the problem. No worries for us. You will improve with time. So that's not a problem. Is it clear to you for us till now, and everyone else as well, guys? Please let me know. Then you can give me a +1 if you are clear till this part. Okay, so basically what we need to do here is we can simply say that we can declare a set data structure. So just a second, I will remove rest of the part so that we can code properly. Okay, so what we need to do here is we can simply declare a set data structure. Okay, and it will be storing the integer data type. So I'll declare the set data structure which can store the integer data type right here. And once this is declared, then I will do what? Then after that, I will simply say that while the head one is not equal to null, so while we don't reach the end of the first linked list, till that point of time, we will keep on iterating. Okay, and since we are iterating, so we will simply keep on inserting the element. So we will say that st dot. So inside the set, we'll keep on inserting. So we'll simply say that st dot insert head data, head one data. Okay. So is this much part clear, guys? Head one data. So we'll insert the head one data inside. So let's say we'll insert this data, and then head one will move to the next node. So head one is equal to head one's next. So we will simply insert this much part, and once this has been done, so once the first linked list is inserted, then after that we'll repeat the same process for the second linked list. So basically, if I'll copy this part and I'll paste it here, so I can just write it as head 2. So after this, you can see that we have inserted the second linked list as well, right? So head 2 is equal to head 2 dot next here, and we are inserting the second linked list as well. Once we have inserted the first and the second linked list both, guys, I hope that my voice is clear. Yeah, so once we have inserted the first and the second linked list, then what we need to do is we need to declare the head node. Okay, so we'll say that node head is equal to new node. Okay, and then what we will do is we can put a value as, let's say, initially -1. That is the dummy node that we are having, and then we can say that node star, okay, current is equal to head. So current will stand at the head, and then what we will do is we will say that while the set is not empty, right, until and unless our set is empty, till that point of time we'll iterate. So in this particular case, what we can say is, when we are iterating now, so if we are iterating, so we need to check the condition. So in that case, I can simply iterate. So what we can do is we can simply iterate through the element. So let's say auto, right, auto element, or IT I can name it as auto IT is to ST, right? So I can iterate using this, or I can iterate using I also, right? So IT will indicate, you can say that IT will indicate what? It will indicate the elements. So we can simply first of all declare the new node. So node star, okay, new node is equal to nothing but new. Then I will write node, and then we are going to insert, then we are going to put IT here. Okay, so basically what it is going to do is, it will like, suppose that initially one is present, so it will make a node for one, and then what we need to do is we need to say that currents next, right, for the current node, its next node should be updated with this new node. So next currents node, next node is equal to this particular new node that we have developed. And after this, we will say simply that after this part is done, then we can say that current is equal to currents next. So we'll move the current node by one. So currents next, current will move by one, and then in the end we can simply return what, guys? We can simply return the heads next, because we are having a dummy node extra in front. Okay, so we'll simply return the heads next node. All right. So yeah, this is how things are going to be. Things are going to look like. Let me just compile this code now to see if it works or not. Is it clear to all of you till now? Sir, for the first time, I'm joining the live session DSA based stream. I'm MCA student, so don't know how to try linked list. How can I solve these questions? So basically, every day for us, what you can try to do is you can try to join our GFG live stream uh, on this channel, and we solve the problem of the day here. So in that case, you will get an idea about new problems every day, and you will get the concept as well. Is this concept clear? Right, problem is how to start DSA from basic understanding of problems. So for that, you can do what, you can solve the problem of the day every day for us. And apart from solving the problem of the day, what I can suggest is you can basically use the GFG practice platform, and you can go to the problem sections, right? And then you can select the easy topic, right? You can select the easy tag, and after selecting the easy tag, you can choose a particular topic for which you want to solve. Okay, let's say you want to solve for arrays, and you can solve some of the easy problems that are asked in some of the companies that you want to apply for. So this is how you can improve. So I am able to solve the problem in linked list, but how to develop confidence? So basically, Varun, if you want to develop confidence, so for developing confidence, basically you should be able to solve the random problems. And if you want to solve the random problems regularly, so solving problem of the day is one of the things which you can do regularly. Why? Because in problem of the day, what happens is every day you get a new problem for a which has a newer topic, right? And it can be hard, easy, or medium level. So it can be of any particular level. So in that case, what happens, it is much more efficient and better for you. So by solving problem of the day, you will get the habit of solving random problems, random topics, and random company based questions. So that is how your confidence can increase. If you can solve random problems now, Varun, then that is how your confidence will get boosted up. So yeah, this is the code for it. So is this part clear to everyone or not, guys? Okay, now another thing, what will be the time complexity of my approach? So if you think about the time complexity, so basically in the set, at most how many, like, see, in the set, at the worst case, n plus m elements are inserted, right? So just let me write it, n plus m elements are inserted inside the set. Okay, so if n plus m inserted are n plus m number of total elements are there, where n elements are in the first linked list and m are in the second linked list. So if they are inside the set, so it will take n plus m log of n plus m time. Okay, this will be the time complexity, because if there are, suppose, x elements, so it will take x log x time inside the set. So if there are n plus m number of elements, so it will take n plus m log n plus m elements. And after this, talking about the space complexity, so since we are using a set data structure, and at the worst it can take how many elements, n plus m elements, so the worst case space complexity is going to be n plus m for my code. How much time should I devote actually when I solve when I'm giving to one question? So at least you should devote 30 minutes at least, I should say. Okay, in the, if you're starting off, or if you're in the mid journey of your coding, so at least you should give 30 minutes. You should try to think about every scenario, try to write some code for it as well. Okay, because in an interview at least you'll get 30 minutes for a problem at the worst scenario. So that is why at least 30 minutes should be, you should try a problem for at least 30 minutes, and then you should try to see the solution or the hints about that problem. You can see if you go down somewhere here, so hints will also be there. So yeah, this is the thing. Is it clear? Like, is this time complexity and space complexity also clear to you guys? If you are clear with the problem, guys, so please make sure to hit the like button, okay, and subscribe the channel as well if you haven't already, and please make sure to share this with your friends as well. Okay, which is better, DSA, doing DSA, which is better, joining DSA course online or offline? If you have time and you live somewhere at a place where you can, if you live at a place where you can join, right, where you can join the offline batches, and if you want the offline interaction, then you can join the offline batch. Otherwise, if you live in a city which is far away from the offline classes, where the offline classes are going, and you want to do the, if you are okay with online studying, then you can join the online course. So whichever you are comfortable with. If you are more comfortable with offline course, then you can join the offline one, if you like offline interaction with the teacher. Otherwise, if you are comfortable with online and you want to save your traveling time and other things, then you can join the online course. I am in hostel in private college. So if it is possible for you, right? If it is time efficient for you, if you think that your time is not getting wasted and you want an offline interaction, then you can join the offline batch. Otherwise, you can join the online batch. Okay, so that, according to that, you can choose. Okay, I hope that this particular problem is clear. So basically, we declare a set, then we do what? We insert the first linked list inside the set, all the elements of the first linked list. Then we insert all the elements of the second linked list inside the set, and after that set will consist of all the unique elements. And then we declare a dummy node head as -1, as I have already told you here, right? This will be helpful for us, and we make our current stand here. Then one by one, current, we declare the new node, okay, and current's next is new, and then current moves one by one. So that is how we get the linked list. And at the end, we need to return what? We need to return the head next. Okay, basically this is the head next. So when you return this particular node, then the rest of the linked list is returned, that is required in the ascending order. Okay, so which GSA course you prefer for understanding? I think GFG's GSA course is much more than enough, so you can definitely check it out. You can join the GFG has several DSA parts. Like, it has the pure DSA course, that is DSA, like DSA by Sandeep Jan sir. It also has the competitive programming course, which has basics of DSA covered, and then competitive programming. Apart from this, if you want to prepare completely for the essay, then GFG, and also prepare for the interview perspective. From the interview perspective, if you want to prepare your subjects like computer networks, OS, GBMS, then GFG has a complete interview preparation course as well. So you can go according to that, whichever you feel is the best for you. Okay, whatever is your requirement. Is DSA difficult to learn for non-tech background? No, definitely not. It is not that difficult to learn. It will just take some time. So if you will solve every day, if you will solve the problem of the day, or if you will use the GFG articles, then that is going to help you out. Okay, so yes, I will just remove this. Yeah, now I hope that everyone is clear with this today's problem of the day. Please make sure to hit the like button, guys, before you will go. Thanks a lot everyone for joining, and please make sure to hit the like button. Comment understood if you have understood completely, and thank you everyone, and I'll see you tomorrow with another problem of the day. Till then, take care everyone. Thank you.